Alright, hello again. We are going to go into the next section that we cover in Chapter 1. That is 1-5, and we are going to look at how we write equations of lines parallel or perpendicular to a given line, or, well, let's just say to a given line. Alright, so that's our objective today. We're going to try to get to the ability to do that. Before we get there, I got to discuss something else with you first. We got to be able to do, again, let's think back to the previous chapter where we did our prerequisite skills. We talked about writing equations of lines, and we said if we can get a slope and a point, we can use point-slope form to get all the way to standard form, or even intermediately get to the slope-intercept form. So we need a slope, we need a line. So I'm going to look at first how to find slope given some information, given different information, given a different line, that type of thing. So for example, and we're just going to jump right in, if I ask you to find the slope, whoops, that was supposed to be a P, slope of the line and we give you 3x plus 5y minus 7 equals 0. So, in this case, we have given you the equation of a line in standard form, right? So, being that it's in standard form, we could say, well, if I need the slope of this, if I get it in slope-intercept form, I can find that equation, right? So if I look at this and I want to get it into the slope-intercept form, that's y equals mx plus b, I need y by itself. So I'd have to move everything else to the other side. So I'd have to subtract 3x and add 7 to both sides, right? And when I do that, I would get 5y equals negative 3x plus 7. And then I would have to divide everything by 5. And I would get y equals negative 3/5 x plus 7/5. So I can see right now that I could answer this question that this is a negative 3/5 slope. Alright, so this takes a little bit of work. This takes a few steps, not too bad, but it's a few steps. I want to draw your attention to something. If instead we look at that problem a slightly different way, and let's look at the general case. Let's look at another example. If I said, find the slope for the line with equation, and let's use ax plus by plus c equals 0. So this is a standard form equation again, isn't it? This is our standard form kind of blank equation we called a, b, and c constants, right? Could we solve for the slope of this? Well, yeah, I mean, it doesn't have to be a, b, and c. It could be s, u, and t. It could be anything. So let's do the same thing. Let's get y by itself. So I'm going to subtract ax, and I'm going to subtract c from both sides. And I would get by equals negative c. I'm sorry, that was on that side. Let's erase that quickly. Got distracted by my own writing. Sorry. Alright, so we would get negative ax minus c. And now we would divide everything by b. So if I wanted to know the slope of this standard form equation, what would the slope be? Slope here would be equal to negative a over b. Well, now think about this. And look at what we had last time. We had 3x plus 5y minus 7 equals 0. And we found our slope to be m was equal to, and again, just to give you a look back, our slope was negative 3/5, right? Right here. So our slope was negative 3/5. Well, let's look at this equation. A was equal to positive 3, B was equal to 5. So if I thought of negative A over B, like we saw to the right there, that would be the opposite of 3 over 5. Isn't that what we got? So when we explore this here as our standard form, and this is just our general case of a standard form, couldn't we always say that this value is going to be the slope? And isn't that a lot quicker than having to do all that solving we did on the previous equation? All right, just to give you another example. If I said, again, find the slope of the line, and let's do this one. Let's do x minus 3y plus 6 equals 0. So, what is our a value? A is equal to whatever's multiplying the x, that's 1. The b value is whatever's multiplying the y, that's negative 3. Using what we found from before, we would have the opposite of a over b, so that would be 1/3. Now, we could go and check that. If you wanted to solve for this, we'd subtract x and subtract 6 from both sides, and we would have negative 3y equals negative x minus 6. So, divide by negative 3, divide by negative 3, divide by negative 3, and what do we get? Y equals, this becomes positive, right? So this is positive 1/3 x plus 2. Here's our slope. Same thing we got here. More chance of an error over here than just doing this. If you can identify a and b in a standard form equation, you can find the slope very quickly. All right. So let's see why I bring that up. Because what we're really talking about, if you remember in the beginning, I said our objective was to write the equations for lines that are parallel and perpendicular to another line. So let's look at what that could look like. We may be asked something like this. Find the standard form of the equation of the line and we'll say that passes through the point let's use 10 negative 2 and is parallel to the line all right 2x minus 5y minus 8 equals 0. All right, so this brings up our situation where we have we want the standard form of the equation of a line, so that we want it, our end result, to be in ax plus by plus c equals 0. All right, we want it in that form. That's what the first part of the sentence tells us. And it says it passes through the point 10 negative 2. So we have our point, right? Looking at just gathering information right now, we have our point here. This is our x sub 1, y sub 1, if we go back to what we were doing before. And they say it is parallel to this line. So they didn't give us the slope. Remember, we need point and slope to write an equation of a line. They didn't give us the slope. They gave us a point, but they said it's parallel to this line. So they kind of have given us the slope, because if I can find the slope of this line, what do we know about parallel lines? Well, we do have a theorem. I'm going to write very quickly, just kind of summarize the theorem, that will say that two lines are parallel if and only if, that's what that means. IFF means if and only if, their slopes are equal. Now, there's some different relationships we can get from this. Two vertical lines are always parallel. Two horizontal lines are always parallel, that type of thing. But it's important here to know that when we have parallel lines, we have equal slopes. All right? So we have a point, and they've given us a line that we're parallel to, so we just have to find the slope of this line. The slope of this line is going to be, well, let's look. A is 2, B is -5. So our slope is negative A, so -2 over -5, that would be 2/5. So now we have our slope and our point. All right, so with our point and slope, we can now go and write everything we need. All right, so let's do this. Let's see, we've got to start with point slope form, right? Just to review, this is our point slope form we're going to start with, starting with a point and a slope. So it's the point slope form. In point slope form, we have y minus our y1. We said our y1 was -2, so y minus a -2, so in other words, plus 2, equals our slope, which is 2/5, times x minus x1, which is 10. So we have this. So now, again, we only need two steps to get to slope-intercept form. So to get to slope-intercept, first we distribute. We leave this side alone, and we distribute. 2/5 times x is that. 2/5 times -10. Remember, you're doing this. 2/5 times -10 over 1. So that's equal to -20 over 5, and that is equal to a -4. So this would be -4. Second step, we eliminate this. Have to do it on both sides to keep our equivalency. So y equals 2/5 x. -4 minus 2 is -6, and we would have this. So we have now arrived at slope-intercept form. Okay, so now look back at the top. Always look to check, did we find our answer? It says find the standard form of the equation of line that passes through that point and is parallel to that line. So we have one more step to finish this. We've got to get to our standard form. So again, let's see if you can remember what that entails. Let's see, I can't go any lower without doing that. All right, so we're here. First thing I reminded you before was we need to get x and y on the same side, right? So x and y on the same side means I'm subtracting 2/5 x. So -2/5 x plus y equals -6. And next step would be to make sure we have everything is all there are no fractions, right? And at the same time, if you remember doing this, a has to be positive. So if I'm going to multiply everything by something, I may as well make it a negative to get this into a positive number. So we need this number to be positive, and we need it to not be a fraction. So I'm going to multiply everything in here by a -5. And when I do that, it'll cancel here, and I will just have a positive 2x. And I'll have -5 times y, and I'll have -5 times a -6 will equal positive 30. And remember, we said we would accept both forms of standard form, either this or this. So you could leave it this way. if you wanted to go one step further and call it this, that is fine as well. The reason I say that is I want you to be familiar with both of these, or I guess more importantly both of these, because you're going to see different textbooks will kind of flop back and forth between those two when they ask for standard forms. So just be aware, these are both acceptable standard forms. It's up to you which one you want to choose. We will accept either one of those. So either one of those down here would be our solution. All right. Let's look at another equation, or another problem, I should say. Let's look at this one. Let's see. Another example. Write the slope-intercept form of the equation of the line let's see, that passes through what is it, 2, -3, and is perpendicular to the line and let's see, we'll use this one, 6x minus 8y equals 5. Alright, so it's perpendicular. We say we want the slope-intercept form of the equation of the line, so we know we're going to be in slope-intercept form when we finish. That should be what our answer looks like. It's an equation of a line, it's passing through 2, -3, and it's perpendicular to this line. So they've given us, again, a clue to find the slope we need to start with our point. But they've said perpendicular, so I want to talk about that for a minute and look, again, I'm going to paraphrase another theorem that tells us or defines what perpendicular lines are. Two lines are perpendicular if and only if their slopes are negative reciprocals. So, I think we have to talk about this, the negative reciprocal. All right, if they are negative reciprocals. For example, if we had a slope of, let's say, 3/7, then the slope perpendicular would be, since this is a positive rational expression, we would have a negative expression, we'd have the reciprocal, so this would be that. All right, so if you have a slope that is any, let's say, s over t, then the slope perpendicular is always going to be the opposite with t over s. Okay, so now let's go back to our question. We need to use the point of 2, -3. And we have to find the slope using 6x minus 8y equals 5. Okay, so first let's find m. And I always, just to remind myself, guys, I write to the side, I need m perpendicular. Because what's going to happen, sometimes you're going to find the slope here and you'll try to use it, when we really need the reciprocal of the slope, because this is the line that it's perpendicular to. So this is a equal to 6, b equal to -8, right? And we can take this and say slope then would be -a over b, which becomes positive, and it would be, would that be 3/4, right? 2 goes into both of those. So that's our slope. Our slope perpendicular, which is what we need, would be -4/3. Can you see a way we could use A and B to find the slope perpendicular right off the bat? Wouldn't this just be equal to the negative reciprocal of -a/b? So wouldn't that just be b/a? So again, you can do it either way. You just need to get to the point where you can find this number and know you're using this. So now we're going to find that equation of the line. We've got our point, we've got our slope. Let's do some work here. We're going to do y minus, y1 is -3, so y minus a -3 equals -4/3 times x minus our x1, which is 2. And 2 steps. Leave this alone. Multiply this out. Distribute that -4/3, negative and negative make a positive, and that would be 8/3. So now we have this, and we need to get this one more step. We're going to subtract 3 from this side. On this side, I'm going to subtract 9/3 because that's equivalent to 3, but it works with 8/3. Okay, I'm just subtracting 3 from each side. I just changed the form of this. If you're not aware how to do that, we need 3 as a denominator, so I just multiply this by that value, and I get the top. All right, so I'm just doing this now. And y would equal -4/3 x. 8/3 minus 9/3 is a -1/3. And it said in the beginning we wanted the slope-intercept form, so we have it. And we're done. Always look to make sure you're answering the question. If it had said, just to give you an idea, if it had said just write an equation, you could have actually used this, because this is an equation of the line in slope-intercept form. Or, I'm sorry, point-slope form. So this is the point-slope form. This is an equation of a line. If they ever just ask you for an equation of a line given those pieces, you can use point-slope form to answer it. This is slope-intercept, and it's good to know all of these because, and we could change this into standard if we wanted to. If you look at standardized tests, a lot of times they'll ask you this question. You got to look at the answers and say, what form are they in? Did they give me the answer in standard form, or did they give me the answer in point slope? Only one of them will be the answer, but it could be in any of these different, I guess, arrangements. So the different forms, I guess is a better word. So you've got to be aware that they could ask for any of these. So be sure to be aware of that. And that's essentially it. That's all we're going to be doing is writing equations of lines that are parallel or perpendicular to other lines. That's what we're going to essentially be asking you. There will be questions just on find the slope of this line given a standard form, things of that nature. But this is as hard as it should get. So if you, again, if this looks familiar, please just don't skip the homework. We are going to be asking you to, as you probably already found out at this point, we are, as you've figured out, we are asking you to submit all your homework. So please do the practice, do it authentically, learn something from this, embed these forms in your head so that you're going to be able to recall them later. This class, more than any other class you've ever taken in mathematics, is going to make you kind of go over everything you've ever done in math and remember everything you've done in math because, once again, broken record time, we are getting you ready for calculus. And in getting you ready for calculus, you have to remember all the math you've ever done. That's the thing that people have trouble with in calculus. Ask any of your friends that are taking calculus. They'll tell you the most difficult part is having to remember everything from pre-calc or accelerated algebra 2 or that class that led them there, all the classes that led them there. They got to remember all that stuff and use it at the appropriate time. And hopefully that's what you're going to get out of this here, is you're going to see when is the appropriate time. How do we use it? And those are the questions we want you to ask. We want to ask why. We want to hear you say, why did you do that? What made you know that that was the right thing to do? We will give you those answers. We will give you those kind of prompts. You'll hear me say a lot of times, I'm just going to show you my thinking. My thinking is this, and I'll go through a problem with you, and we're doing our live daily broadcasts where we're working one-on-one. I want you to ask these questions so I can answer them and demonstrate the kind of the thought process. I do that a little bit here, but I do it even more when you show up for class and we go through those problems. So again, do your practice, do it well, get ready for our assessments, always. All right, have a wonderful day.